Hey guys, welcome to the Physics. Let's get started. Alright, so we're going to be doing a few different things in today's video. We're going to start by going over some of the centripetal force fast facts that I made. And these are just things that I've boiled down over my time of taking physics and engineering courses that I have found important. And these are the things that I actually use when I'm solving problems. So if you feel like you need a more in-depth, derivation and explanation of why these facts are true, that's perfectly fine. And I would recommend going to someone like Khan Academy for that. But I just wanted to boil it down to these 4 facts to make it as simple as possible for you for what you might actually use. So the first point here is that centripetal force always points towards the center of motion. So let's say you're traveling along this circle here, and we know that this is your path, and so velocity is always tangential to the path. So this would be your velocity. And if you're traveling along this path, then your acceleration and force would be pointing this way. So this would be your centripetal force, because this is the center of your motion. And so your centripetal force always points towards the center. They love to ask you about these kind of questions on AP tests, college tests. What's the direction of the centripetal force? It is not pointing outwards, but it's pointing inwards. So the second point here is probably the most practical one that you'll use in a lot of your problems. It's that the centripetal force is equal to the mass of the object that's going around the circle times its velocity squared divided by the radius of motion. And I'll just draw that radius here. So that would be like this, and this would be r. So divided by the radius of motion. The third point, this is the one that was hardest for me when I was studying centripetal force, is that the centripetal force is a net force. So let's just do an example of something in linear motion that we might all understand a little bit better. So let's say you have, you've got an object on ground and it's resting here. So you would probably have a normal force pushing up on the box. You would probably have a gravitational force going down, and let's say that someone is pushing down on the box with a force F at an angle of theta. So just like how in this problem you would probably sum your forces in the y, and that you would do n, and we'll say positive is up, positive to the right. So just like you would say sum of forces in the y is equal to n minus mg minus f sine theta. This equals f y net. You would do the same thing for the sum of forces in the x direction, and you do that would equal negative f cosine theta equals f x net. So this is the sum of your forces in these directions. Okay. When we're dealing with centripetal forces and you're traveling in circular motion, you sum your forces pointing towards the center of motion, and that's your centripetal force. So I'll do an example here and lay it out a little bit more clearly. This is an example that many of you have probably already seen in your classes, and I will just draw it out. So I know I've had to deal with this problem many times. So let's just say that you are driving in a car along a racetrack, so you're going in circular motion, and the racetrack is banked at an angle of theta. And so like here's the center of your motion, and the car is just kind of doing this path around the circle. I'm just going to remove these lines because when we're doing the problem, they can get confusing. But just know that we're traveling in circular motion. This is the center here. So you've got some forces. You've got force of weight. You've got your normal force. The tendency of the car is to probably slide down the ramp. So we know that there's a force of friction that is holding the car up the ramp. And so I don't want you to get lost in why did he draw the friction that way, or how is he getting these angles? Don't get lost in that right now. I just want to explain how centripetal force works as a net force. So similar to how we summed our forces in the y and x direction, we are also going to sum our forces in the radial direction here, because we're dealing with a centripetal force. We're working in circular motion. So we're going to break this normal force into a radial component and a vertical component. So this would be, we've got, let's say, positive radial direction this way, positive y direction up to the top. So this would be ny, and this would be nr, and this would be fr, and this would be fy. And so I'm just breaking the normal force and frictional force into horizontal and when I say horizontal, I mean radial components and vertical components. So now what we're going to do is we are going to sum our forces in the y direction, just like we did above. Sum forces in the y, and you'd get fy plus ny minus mg equals fy net. Okay, so now we're going to do the exact same thing. We did the sum of forces in the y up above. We did sum of forces in the x up above. We did sum of forces in the y in this case down below. And now we're going to sum our forces in the radial direction. So that would be force of friction in the radial minus normal force in the radial. And we don't need to include the gravity because there's no component of gravity in the radial direction. And this equals F radial net. Now up above in our fast facts, we said that the centripetal force is a net force and it equals mv squared over r. We see that this is net and it equals mv squared over r. So the last fast fact that you will need to know and that you might use in your problems commonly is the fact that you will typically see these problems with constant speed. It becomes a lot more simple to calculate your centripetal force when your v value is not changing, and that should be a trigger to you to know that when you see a constant speed working in circular motion, that is centripetal force, right? Thanks for watching this video, and I'll be posting centripetal force part 2 and part 3 videos that will give some more examples about how to use these fast facts in your problems.